Welcome to Brain Vision.
For this problem on the topic of alternating current circuits, we are told that when the switch in a given circuit is closed, the capacitor discharges. This occurs when charge moves from one plate to the other. In part B, we know the amount of charge remaining on each plate of the capacitor as a function of time. And in part C of the drawing, the switch has been removed and an AC generator has been inserted into the circuit. We are given the values for the resistance, the RMS voltage for the generator, as well as the frequency for the generator. If we know the time constant for the circuit in part A, we want to calculate the RMS current in the circuit in part C. Now the RMS current RMS in the circuit in part C of the drawing is equal to the RMS voltage divided by the impedance Z. So RMS is equal to the RMS voltage divided by the impedance Z. Now the impedance Z of a series RC circuit we know, and we also know that the inductance is 0. Since there's no inductance in the circuit, we can also have that the impedance Z is equal to the square root of R squared plus X C squared. Now the resistance R is known and the capacitive reactance XC can be obtained from XC is equal to 1 over 2 pi F times C, where C is the capacitance and F is the frequency. But we also know that the capacitance is related to the time constant tau of the circuit in part A of the drawing. And this time constant of an RC circuit is the time for the capacitor to lose 63.2% of its initial charge. And it is equal to the product of the resistance and the capacitance. So if we substitute Z into the equation for I, we get the following. We get that the RMS current RMS is equal to Vrms over Z, as we stated above, and this is Vrms divided by the square root of the square of the resistance plus the capacitive reactance squared. And we also know that XC is 1 over 2 pi F times C. So we can substitute this back into equation 1, which is the equation above, and we can write the RMS current from above, IRMS, as Vrms divided by the square root of R squared plus 1 over 2 pi F times C all squared. And lastly, we can substitute the capacitance C as tau over R and put this back into the equation. And we get this to be V RMS divided by the square root of R squared plus R divided by 2 pi F times tau all squared. So remember, we know that tau is equal to R times C, or simply R or C is tau over R rather. So in this equation, we can substitute our values since all of them are known. So this becomes 24 volts, which is the RMS voltage, divided by the square root of the resistance, which is 18 ohms squared, plus the resistance again is 18 ohms divided by 2 pi times the frequency of 380 Hertz for the generator multiplied by the time constant tau, which is 3 times 10 to the minus 4 seconds, and this is all squared. And so calculating, we get the RMS current in this part of the circuit to be 0.78 amperes.